All right, so now we're talking about 2.5 still. Now we're going to actually factor. We're going to go through the steps of factoring. There's 5 steps to this basic factoring, and we're going to factor and solve. All right, here's your first example. 6x squared plus 12x is equal to 0. Okay, the directions are going to say factor and solve, or they might just say solve. And you have to know to factor, but hopefully they're going to say factor and solve. So what's your answer going to be? Down here, what's your goal of your answer? X equals a number. How many x's do you have? 2. And so how many answers should you have? 2. They might be 5 and 5, and you get the same number twice, but you better be looking for 2 answers. Okay? All right, step number 1, set it equal to 0. Write that down. Step number 1 is set it equal to 0. Are we already equal to 0 in this problem? Yes. Yes, we are. So what's step number 2? We don't know. All right, how about this? GCF. What does GCF stand for?
Greatest common factor.
Greatest common factor. Notice I didn't say common factor. 2 is a common factor here. 2 goes into 6x squared. 2 goes into 12x. It is not the greatest common factor. You must pick the greatest common factor. Let me talk about how to do that. I'm going to break this down, and I'm going to break this down. 6x squared breaks up into 2 times 3 times x times x. 12x is 2 times 3 times 2 times x. Isn't that right? 6 times 2 times x? So, what numbers and what variables do they have in common?
2.
They got a 2 in common, they got a 3 in common, and they got a x in common. Now, you might have been able to look at that and tell. 6x squared and 12x, they're going to have 6x in common. Okay? 2 and 3 and x. I'll circle. 2 and 3 and x, and 2 and 3 and x. That's what they have in common. What is 2 times 3 times x? It's 6x. So in this problem, your GCF is 6x. All right, questions on GCF? We'll do more examples as we go, but that's step number 2, is find the GCF. Step number 3, pull out GCF to the front. Pull out the GCF to the front. What does that mean? When you're factoring, you're taking this fairly easy binomial, you're pulling out the GCF to the front. You're making it bigger. You're expanding it. I'm going to pull 6x out to the front. Then I'm going to have this binomial on the inside. You got to think about the hardest part of this type problem is figuring out what goes in the parentheses. When I pull out 6x to the front, you have to be able to figure out what goes here. And I'll show you how you figure that out.
What's that?
You take the 6x squared and you divide it by the GCF, 6x. You take the 12x and you divide it by the GCF. You divide out that GCF. You pull it out to the front. What is 6x squared divided by 6x? The 6's cancel, the x's cancel, and I just have an x. So x goes right there. I pulled out a 6x to the front. How about 12x? What is 12x divided by 6x? 2. They cancel out, and I have plain old 2. So this is x plus 2 is equal to 0. Now, what kind of problem does it look like?
An easy one.
It looks like an easy one. It looks like what we just got done doing. 2 things are being multiplied, and they equal 0. Right? So what must be true about both of them? One of them equals 0. Right? So we set them both equal to 0. 6x equals 0. X plus 2 is equal to 0. This is kind of a long way. I divide both sides by 6. X equals what? What's 0 over 6? 0. What about over here? Subtract 2 from both sides. X equals negative 2. So x equals 0 and negative 2. 0 and negative 2 are my 2 answers. Okay, let's see if we finished out. We pulled out x to the GCF to the front. Step number 4 was solve. Step number 5 was check. Write all 5 steps. Pull the GCF out to the front. The hardest part is number 3. The hardest part of the whole setup is number 3. Pulling out the 6x and knowing what goes in the middle. Knowing what goes right here. That's the hardest part. Okay, let's check it. Where does the 0 go? If I want to check it, where does the 0 go? It goes right there. What's 6x squared when x is 0? 0 plus 12 times 0. What is that? What's 0 plus 0? 0. Okay? How about negative 2? Where would it go? Right there. What's negative 2 squared? 4. What's 4 times 6? 24. Alright. What's 12 times negative 2? Negative 24. What's 24 and negative 24? 0. So do they check? Yes, they do. Is it nice that every single problem will be able to check? Sure, your calculator will do it for you. You can type all that in your calculator in one step. The Casio calculator will knock it out for you. Okay? Questions? Any questions? All right, let's do another. Let's do another example. Let's see what we got here. First step.
Set to 0.
Well, very good. Say it again.
Set to equal 0.
All right, you have a choice. You could either move this stuff over here, or you could move this stuff over here. And I'm going to give you a hint that will stay with you the rest of your mathematical life. When given that choice, you should always try to keep the x squared positive. Write that down. When you're setting it equal to 0, you should always try to keep your x squared positive. In this case, x squared is positive over there on the left-hand side, the 9x squared. So given the choice of which one to move, which one do you think you ought to move?
21x.
21x over. How do I move it over if it's positive right now?
Subtract.
Subtract 21x from both sides. 9x squared minus 21x is equal to 0. Great. Step number 2.
Greatest common factor.
Greatest common factor. 9x squared, 21x. What goes into both of those? What is the greatest common factor?
3.
3 what?
3x.
3x. X goes into x squared and x. So I pull a 3x out to the front. Here's the hardest part, is knowing what goes inside the parentheses. I pull the 3x out. Most people can figure out the GCF. Most people can set it equal to 0. This is the hardest part. How do I figure out what goes here and here? I take that and I divide it by the GCF. Some of you can do it in your head. What's 9 divided by 3? 3. What's x squared divided by x? X. Exactly right. How about this part? 21x. What is it? Divided by 3x. If you have to do it separately, 21x divided by 3x, if you have to do that separately, great. Is it positive or negative?
Negative.
This problem, it happens to be negative. No big deal. At this point, you really shouldn't have to do any more work. At this point, really, you ought to be able to go straight to the answer. You have two answers, right? What is your answer going to be here?
3x.
Equals 0. And what would your answer be?
0.
Just 0. Right? When the x is sitting out there by itself like that, 3x, I'm going to say 3x is equal to 0, x equals 0. That's the only thing it can be. That's the only thing in the universe that it can equal. So x equals 0. How about this? Can you do that in your head?
Yes.
Right? We did it earlier. What do?
7 over 3.
Move the 7 over, divide by the 3. You get a fraction, so what? What is it? 7 over 3. So your answer is 0 and 7 over 3. 7 doesn't divide by 3, so you get some improper fraction. Yes, Marla?
The first part again, the 3.
Pulling the 3 out? Yes. All right. Let me erase this right here. You ready? Quiet, please. When I pull out the GCF, I'm sitting right here. You with me? I'm taking that and I'm dividing it by 3x, because 3x is my GCF. I'm taking that and I divide by 3x, because 3x is my GCF. 9 divided by 3 is 3. X squared divided by x is x. 21x divided by 3x is just negative 7. That's the hardest part, is figuring out what goes inside the parentheses.
And then, how did you get 0 for the first one?
I said 3x is equal to 0. I divided by 3 on both sides. X equals 0 over 3, which is just 0. Okay, good question. How long?
Close to 10.
Okay, thank you. Yes?
So you got 6 over 3 by changing the negative 7 to a positive and just
I
divide.
move that over and divide by that number.
Okay.
It's every time. It's just like that. Every time. Okay, good questions. All of these are good questions. Anybody else? Anybody else have a question? Yes?
What if you can't pull out a GCF?
Then we have to use a quadratic formula, which you don't yet know yet. I mean, maybe you've done it a little bit, but that's what we have to do. And we're not there yet. We're just let me say this. We are building a gigantic stadium. The name of the stadium is called Factory. Okay? Today, all we did was, what are most stadiums? Right? Most stadiums are bowls or have some kind of hollowed out point. Okay? Today, we started building this tremendous 100,000 people stadium. Okay? Factoring is a huge concept that you will do the rest of your mathematical career. Okay? Today, with this basic factoring and solving basic equations, we started on this gigantic stadium, right? We laid the foundation. We just dug a very shallow pit today. We've got a lot of things, quadratic formula, being able to graph when it has 3 terms, okay, being able to graph when A is not equal to 1, being able to factor when you have 4 terms, all of that. What happens when it's prime, imaginary answers. Factoring is this huge mathematical concept that we do in Math 1 and Math 2. All we did today was just barely scratch the surface. Okay? Yes, sir.
Like what in like life situations, like what would you use this for?
There's lots of different things that you have to use factoring on. The main thing right now is problem solving. Can your mind, in your head, figure out what the GCF is and pull it out front? Can your brain figure out when I divide both sides with 3x and this is what I get? Think of it as mental exercise. You're literally opening up your brain to be able to think more abstractly. Okay? Are you going to use it every single day in your adult life? No, you're not. But being able to solve a problem and say, what times what gives me that? What times what gives me that? You see my point? That's what we're working on, is mental exercise. Good question. All right, how much time are we at?
12 minutes and 1 second.
All right, kill it, and we'll do one more example.